Okay, so next we're going to talk about builds on this idea of continuity, what it means to be a continuous function. And this is a very important result, something that is true if you have a continuous function. And it is called the intermediate value theorem, the IVT for short. So I want to start this off by posing a question to you. Suppose that at noon it's 75 degrees outside, and then by 3 p.m. the temperature has risen to 94 degrees. What can you say about all those temperatures in between? For instance, was there a point during the day where the temperature was 80 degrees? Was there a point during the day where it was 90 degrees? Was there a point during the day where it was 100 degrees? What do you think? Okay. Well, I would dare say that the temperature, if you modeled a graph based on time on the x-axis and temperature on the y-axis, how hot it is during the day, it is going to be continuously changing. You're going to be going up, you're going to be going down. It's not going to instantaneously go from like 40 degrees to 80 degrees. It's going to gradually go up, gradually come back down. Okay, let's think about something else here. So here's another question for you. So this is a true story. When I was in 9th grade, I was 5 feet tall. Very sad. Now, look at me now, I'm 6'2". So was there ever a time that I was exactly 6 feet tall? What do you think? Okay, well, of course the answer is yes. I mean, how could I possibly go from 5 feet to 6'2" without hitting everything in between, right? And again, this is because my height as a function of time is a continuous function. I'm continuously changing my height. Getting a little bit taller, a little bit shorter maybe sometimes, but if you know the starting point, you know the ending point, you know that everything in the middle must have been hit as well. Okay, so these are two examples of the intermediate value theorem. There are many, many more that we're going to do in class. Here's what the theorem says, and it's very math heavy, so let me just kind of walk you through it. So it says that if you have a function, we're calling f of x, and it is a continuous function, so continuous, remember we have the baby definition, you can draw without picking up your pencil, and we have the more grown-up definition, which is slightly more complicated. But if you have a continuous function on a closed interval, so we're working just on a closed interval from a to b, and then k is just any number that's between f of a and f of b. So f of a would be the final or the beginning output, and f of b would be the ending output. So essentially, going back to the problem that I was just discussing here, a and b would represent time. So a would be 9th grade, whatever year that was, and b would be now. And f of a is how tall I was in the 9th grade, and f of b would be how tall I am now. Does that make sense? Hopefully it does. And so if I know what's happened in the beginning, that's f of a. If I know what happened at the end, that's f of b. You just take k to be any number in the middle there. What the intermediate value theorem says is that there's at least one number. There could be more than one, so I could be going back and forth between 6 feet and 5 feet, just having some kind of wild oscillation, if you will. But there's going to be at least one time, maybe more, inside of that interval where f of c, so f of my new number, that one time that I'm talking about, is equal to k. So this is a very complicated theorem here if you're just reading it, because it's all letters, it's all really terrible stuff. But all that it's saying is that if you know what's happening in the beginning, you know what's happened at the end, everything in the middle has happened at some point. We don't know where it happened, but it definitely happened somewhere. Okay, we're going to play with this more in class. See you soon.